Okay, so welcome. My name's Mark Doran. I am the president of the UEFI Forum for my sins, and I'm also an Intel fellow. And I'm going to give you both titles because this talk is sort of, in a sense, in two pieces. I'm going to talk a little bit about what we do under the aegis of the Forum, which is primarily scoped towards working on formal de jure standards for firmware interfaces. And then I'm going to switch gear and talk about implementation. Technically speaking, the Forum doesn't really have any remit as far as implementation is concerned. But given that this is a conference about Linux and open source and doing real work, this code is, of course, the real work. So I want to tell you a little bit about where we are with that aspect as well. OK, so it breaks down into a quick... Is there anybody in the room that doesn't know what the Forum is, what we're about? I'm going to fly by that first foil very fast then. Good. Of operation. This turns out to be important for, especially for embedded kinds of things. So the canonical example that everybody quotes is, think about a backup camera in your car, right? As soon as you hit the reverse position, you really want the camera to be lit up right then, which could be almost immediately after you turn the ignition on in the car. So getting that graphics head lit up really fast is pretty important. The reason that we had all three specs come together all at once comes down to non-volatile memory support. New NVDIMMs and devices that are providing non-volatile storage that sort of kind of looks like memory or block or both, depending on your instantiation of it. The touch is relatively light. There isn't a whole lot of information in the specifications, but we needed to do things like make it possible to describe this in the memory map for the machine. And it turns out that shards of the memory map description find their way into all three of these specifications. So that was sort of the galvanizing factor to bring all three out at the same time. OK, so what are we up to at the moment? Security is one that gets a lot of press around UEFI. It's probably the single topic that's made us most famous in the world in the last 2 or 3 years. I'm sure there's nobody who will have escaped the conversations that, I guess Matthew Garrett was one of the original flag wavers here, right? Hey, this secure boot thing might actually make it very difficult to install Linux on machines that were pre-configured for Windows, for example. We have a goal of improving platform integrity in general for security. So we're not necessarily interested in, the other thing I always get accused of, right, is like, oh, those firmware guys, they're trying to put DRTM right into the firmware, right? Or DRM kinds of things right into the firmware. Well, no, actually, that's not necessarily what we're after. It's more about making sure that the firmware isn't the place where the platform can be attacked by malware. At least that's our objective. So Secure Boot is about keeping that malware out of the pre-OS space. It's not about OS lock-in, which is the worry that people have, but it could be used for that. And there are certain cases where that's actually kind of an interesting proposition. So think about a kiosk system, for example, right? You don't want somebody walking up to a kiosk system in the middle of a retail store and reinstalling the OS. In that environment, it sort of makes sense to lock down the system software payload a little bit more. So if you read the way the interfaces are described in the UEFI spec, you can construct a policy that says, OK, I'm going to lock this machine down to the point that only the pre-installed OS may ever run. That's a way to use the interfaces that are there. But equally, you can have what we typically have on general-purpose PCs today, which is they come pre-installed. There's a set of keys in there that allow you to install other things as well. You can use shim and other pieces of infrastructure to be able to boot, install, and run other operating systems as an aftermarket operation if you prefer. And that's typically what we expect people to do. So that's kind of a cheap way of telling you there's mechanism in the UEFI spec, but as much as possible, we stay out of the policy space. So it's sort of up to the vendor to decide how they put the interfaces in and then which ones they exercise in which ways to come up with a policy. Obviously, a general-purpose PC and a kiosk system, maybe you've got quite a different approach. The work that's ongoing right now is to go after making things simpler. So I mentioned shim, right? Introducing that to a platform and getting all the right keys in for that. If you want to be in the business of putting your own keys into the platform, right? Build and sign your own kernel. and get that to work in a secure boot-friendly fashion. It's all possible, but right, it's not exactly walk up and use at present. So we're trying to think about ways that we can improve the infrastructure support in the specifications so that things like dual boot and adding extra OSs aftermarket are just that much easier to do, and people less skilled in the art, if you will, would have access to those kinds of facilities. Okay, firmware update. We certainly want to make it possible to do initiate firmware update from OS present space. The idea of booting to a DOS floppy and doing your BIOS upgrade from there. Hopefully we've seen the last days of that. In general, customers don't want to learn a different interface to be able to do whatever they need to the platform. So having firmware updates show up, whether or not you have to do a reboot to do the firmware update is sort of a different question than how do I actually find an update and command the platform to install it. So there's a lot of thought about what we can do to make it possible to initiate OS present update. Today, most firmware updates that we ship into platforms tend to come as a complete replacement for the existing BIOS. But it turns out that there's support in there for doing updates on a more fine-grained modular basis. So you could update the ROM for a particular video card independent of the rest of the firmware, or you could update the mass storage drivers. Somebody found a security bug in one of the mass storage drivers, and we want to update just that piece, right? So that possibility exists. And that goes for things that are part of the motherboard as well as things that could be add-in devices, right? Increasingly, we're seeing less systems out in the world with slots, but they still exist, and you can still plug in something that might have a ROM attached to it that might need firmware updates separately. So the mechanism that we have is able to address adding devices or cards just as well as it is the motherboard. This idea represents big change for the BIOS ecosystem for a number of different reasons, right? The modular versus complete motherboard image, that's certainly something that we haven't historically done. The other thing here is I'm trying to persuade the BIOS ecosystem to do a better job on providing support for BIOS updates after systems have shipped into the market. It's pretty typical now that as the machine ships and maybe 3-6 months after, you can get ROM update images occasionally from the vendor that supplied it, but past that, probably not. So if you've got a machine that's a year old or maybe even 2 years old that's still doing productive work for you, and then somebody finds a security vulnerability in it, in the firmware, in the way that historically the BIOS ecosystem has managed its work out in the ecosystem, you'd kind of be high and dry at that point. Probably no way to get a fix for that, short of buying a new machine, which seems overly burdensome, let's say. So by building some of this infrastructure, my hope is that we'll be able to encourage that machine producer ecosystem to do a better job of supporting these things longer term, and when security issues, for example, come up, that we'll have more likelihood of being able to get a fix and have a way to deploy it reasonably out in the field. But this is a big change in terms of the business model that these guys have around supporting systems out in the field too. So some amount of pull from people asking for this kind of feature from their system manufacturers would be useful. So if I could get your help to do one thing through the day, maybe this is it. Ask for this early and often. Okay, let's see. For the time running up to Windows 8, Windows 8.1, just to put you in time frame term, a lot of our emphasis was on working on features for client systems. So the secure boot thing was primarily aimed at client systems. And a lot of the work we did in the implementation side of things to improve boot speed, the way we interleaved the OS boot and the OEM system logo to take out a large chunk of time by having those two things operate in parallel. All of those things were sort of client-oriented. Now, I think we're shifting our focus a little bit more towards the enterprise side and server class systems as the next set of constituencies that we want to spend a bit more time providing support for. So you see the network boot kinds of things. That's obviously a data center kind of technology. What we're doing with supporting RESTful APIs for the Redfish and data center manageability, and I think more of our work will go towards that enterprise cloud class of system, particularly when it comes to bare metal OS absent kinds of scenarios, right? So I don't want to have you guys walk away and think that we're trying to supplant what the OS needs to do. My rule of thumb is if you can defer work to having OS present code do it rather than have it done in the firmware, deferring is a better idea. Right? You've got more capability, more facility, more resource to be able to do things OS present than you do in the firmware. But in the case in a data center where you've got a bare metal machine that just came out of the skin, out of the cardboard, and all you've got is the skins and the raw hardware content with no software on it at all, you really want to have some reasonable way to provision that. And you've got to get an OS loaded onto it in the first place somehow. So some work on that space is probably where we're going next. So complementary to the things that are going on in DMTF with Redfish, for example, is probably the best example. Okay, let me talk about testing a little bit. So I've only got one foil here, but it's kind of important to me. So no surprise, right? The history, if you go look at what we've done in the way of testing firmware in general before it ships out of the market, almost all of the history is you gotta pass the Windows logo test, right? And that's all people care about. And you can see why, right? There's motivation there because there's a financial incentive to the OEMs who are doing this kind of testing to pass that test because it improves the cost of shipping Windows on that platform for them if they pass it. So Microsoft's done a bang-up job in focusing everybody's attention on that as the main axis for testing. But of course, as we've learned, that doesn't necessarily set you in the best situation for being ready to run Linux out in the marketplace. So I think our aspiration is that it would be nice to have the OEMs do as much testing for Linux readiness as they do for Windows testing. Now that's an aspiration, right? It'll take us a while to get to that point, I think, but it doesn't seem necessarily unreasonable. There are market spaces now where Linux is ahead of Windows in terms of market share, right? I do not understand why the OEMs are reticent to do testing on Linux readiness, right, at all, with those kinds of stats in mind. So Matt will talk a lot more about Love OS in a session that will follow this one. But the way I mentally model what Love OS is sort of the moral equivalent to an HCT for Linux, right? HCT being the Windows, are you ready for the logo test? The biggest thing I hear is a request from the OEMs. When I say, okay, go do more Linux testing, the biggest thing I hear back is, well, which distro do I test, right? And what configuration? And how many different variations of testing do I need to do to be sure that I'm ready for Linux out in the marketplace? They view it as a very difficult problem to get their arms around. So if we can provide them one thing, right, a live image that they can just toss on the system, run it and get a yes/no answer in the same way that the HCTs do, that will at least take away the it's too complicated objection, right? Which is the hardware compatibility test. I think that's right. Something like, it might be conformance instead of compatibility. I can't remember exactly, but it's basically the set of right. So it's basically the set of tests that Microsoft give you. But they've gone away from that. Right. They don't certify so much anymore. The letters don't really mean much anymore. Yeah, that's kind of why I had it in quotes, right? Because I think you can expand it a number of different ways. But you think of it as it's the test set that you run, and if you get a pass on it, Microsoft can audit that, and you'll get your logo with the commensurate reduction in the price of your Windows license to ship with the system to the market. So let's see. So Love is already available. It's already out there. If you aren't running it already, you should be. If you're in the business of system testing in general, please. And there is some amount of coverage. It's not as broad as we would like. There is a ton of opportunities to contribute more if you would like to help expand that, right? And I can see the test people like nodding furiously. Please add more. And it's not hard to do little pieces by increment too, right? Many of these tests are pretty modular in and of themselves, and if you feel like it, you can add one test for one thing that's bothering you in terms of compatibility for distros and configurations that you particularly care about. But probably the biggest thing is asking again, right? We should all be asking of our system providers, right? Have you done this level of testing at least, right? Is this machine ready for Linux in some measurable form? And if you can't get a sensible answer as to what that would mean, point them at LoveOS and tell them go find that, right? It has a number of other test infrastructure all rolled into one, and it's kind of our best known set of things that you can do to make yourself as ready for Linux as you possibly can. So, I really plead with everybody, please find this, try it, use it, try it on your own system. And if you find issues that come up as a result of running it, please shout about them loudly, right? Let's get some visibility here. Okay, so let me switch gears a little bit here and talk a bit more about what we're doing with open source. So this is kind of the point at which I take off my UEFI president hat on and put my more Intel hat on maybe a little bit. So I think we're doing a pretty good job with specs, but of course the rubber meets the road where the code shows up. So that's an important piece of our work going forward. At least for Intel's part, in terms of producing firmware, we've had I don't know how you would describe it, an epiphany maybe, right, internally with the brain trust that collectively manages this for all the different business groups inside of Intel. We've flipped now to a default stance that when we're producing firmware, open source delivery of that is the default option, right? So now we have to get the hardware guys who claim we're writing code that reads on IP to prove to us that what we're shipping out actually does still need protection. And there are some things that we're not going to get the hardware side of the house to give up the right to, in the sense of being able to ship fully open code for a while, right? And that ideally, in the end game, I'd like to get to the point where it's 100% open source for everything that we do. And on the Quark platforms, we have that already. But that's only on the Quark product line. So we're working on it, and we'll get there, I hope. But at least now the default stance is, okay, everything's open, now tell us what we need to protect and keep that perimeter to the minimum. So that is a big mind shift, a big shift in approach, at least as far as Intel is concerned. So if you haven't found it yet, TianoCore.org is the open source project home that we have for delivering our implementation work. It's got a BSD-style license. If I had it to do over again, it would be Apache. But when we started this, Apache with the contributor clause did not exist yet. So what you see out on TianoCore looks a lot like, if you have a lawyer interpret what's there, we have the BSD outbound terms for licensing, and there's a contributor agreement on the front end. If you take those two together, compare it to what Apache is in legal terms, it's equivalent. It's the same thing. But since it's been there for 10 years, I did actually ask them a year ago whether I could change it and make it Apache now, but they said, well, you'd have to go back and find every person that's contributed code ever to the code base and get them all to agree to relicense it, and then you could change it. And since it's equivalent terms anyway, do you really want to go to the energy to go do that? Anyway, so I ended up leaving the license as it is. I would point out that the BIOS world is kind of new at this, right? So that TianoCore site's been out there since 2005, and we've been putting code out there for a while, so that's 10 years, right? But this is what, Linux's 24th birthday this year? So we're still kind of the new kid at this, and I think you can tell that, right? If you go look at the project, go visit that site, we're still not very good at landing, right? Where do I go to find out what's going on? How do I contribute? How do I find the piece of code that I care about for my particular machine? So we're looking at reworking some of the website and the way the community works to try and improve participation and accessibility there. But we're kind of the blind leading ourselves as blind at the moment, right? So I would seriously welcome help to get this right. If anybody is feeling motivated to give us some guidance there, that would be welcome. And I think we need that because these statements in italics are all things that have landed in my inbox in various chunks of email in the course of the last 3 months, right? So there is clearly still a lot of angst about what we're doing and how how great it is or is not in some respects. And a lot of it comes down to concerns about implementation of one sort or another. So there's sort of two classes here, right? There's the, maybe the spec is okay and the implementation has some problems. The version that I find in binary form in my platform is not representing what I see in the website. So how did the code get broken in the meanwhile? And then there's this whole thing about it takes a really long time to get a bug fix out of us. This comment was actually internal to Intel, right? So it was one of our people working on enterprise class benchmarking on one of the new server class systems that we have. And you would have thought, like internal to Intel, right? They find a bug, send the bug report in, you would think we'd get that fixed fairly quickly. Well, no, it was taking them upwards of 2 weeks because of the way that we do firmware releases to the open source. They were going through this huge heavyweight validation process before they would release anything, even to internal audiences. So we're not helping ourselves in logistical terms in how we're organized either. So that's kind of, bearing my soul a little bit, and we're showing you all the dirty laundry all at once here in a sense, right? But even with Intel, we've got a lot of work to do to improve how we cooperate with folks outside of the firmware ecosystem. But we recognize it's a problem, and we're trying to work on it. So there's probably a lot. Some of these things are pretty hyperbolic in the way they come in. I didn't put any of the unprintable language versions of pieces that came around these, but there definitely were some. But hey, we're at least trying to pay attention here. There are clearly some things that we've got to go work on. There are three categories of code that I want to talk about, and platform code is the one that I think is the biggest bugaboo for us to get our arms around. There's silicon initialization code. That's the stuff that the hardware guys typically still want us to have be protected by a license that can't be open source at present. There's the superstructure code, the interface code that implements all the things in the UEFI specification. How do you transfer control to the OS? And then there's stuff in the middle, the platform code, that does all of the initialization of the particular platform elements that you've got. And this, I think we've come across the idea of referring to this as a jungle in a sense. And it's made that way for a number of different reasons. A lot of the platform code is written to specifications that are not public. So finding your way through that platform code can be pretty exciting, right? If you don't have access to all the internal specifications, you're kind of left out in the cold. We supply reference implementation code that we give to all manner of people out in the industry as, quote, sample code. And what that usually means is the validation guys wrote it, and they used it to turn on the silicon and make sure that all the registers had the right answers in when you poke them and things like that. And they called it good and then said, here, have that. And it really wasn't ever intended to be code that was sensibly screwed together for the way the system needs to operate 99.9% of the time in the production world, right? Where all you want to do is turn the machine on, get the firmware out of the way as fast as possible, and get to the OS. So some of the things that happen with that code, it's like giving weapons to small children, right? You don't necessarily always get the outcome that you would like. It tends to be kitchen sink code too. I couldn't find a good image for including everything, so I just found a picture of a sink that had the most fancy imagery in it and called it good. The validation guys are, of course, interested in touching every last thing in the platform. So a lot of the sample code that we ship out has things that you would never need or want or use in a production class platform, and a lot of times that finds its way into the end result in a production system.
I've seen a 19 megabyte Ethernet driver.
Yeah, right. So there are some pretty exciting things that are exhaustive, and if you're into validation and testing, that's pretty useful. But if you actually just want to get packets across the network, right, it's probably more than you need or care about. And of course, configuration gets to be a fun and exciting game too. The server guys especially, I run into this. I was talking about the note I got from the performance guys inside Intel that work on benchmarking kinds of things. The server class systems typically have pages and pages of these very weird esoterically named setup options that you can tweak here and there, and figuring out the right profile of those to go fast for a TPCC versus a spec benchmark or whatever it is that you're going to, very complicated. And of course, they're all different because all the different system vendors have different ways of describing, in some cases, the same thing or different knobs and dials that they give you for their value add content in the platform. So that's an area that makes it difficult to find your way around as well in this platform code. So what I think we're trying to mentally make the leap to here is figure out a way to bridge over the top of the jungle and avoid having to run into some of those pitfalls. So certainly all the work that we do on open standards we believe is helpful towards that. Maximizing the amount of open source code that we can put out there. I think we're firmly convinced that if we can put more of the platform code into open source, we'll get more eyeballs on it. And the 19 megabyte Ethernet driver that really doesn't have a lot of useful function in it, we can probably start getting rid of some of that by inspection. So, you know, no news to you guys, right? This is typical payoff for moving projects into open source that you would expect. We're just thinking that it's time to apply that kind of methodology to this strange platform component, code component slug in the firmware space as well. We are definitely trying to minimize the amount of components that read on IP that we can't share in open source form as much as possible. If you've come across the idea of FSP that Intel's been talking about for a little while now, that's the firmware support package. Imagine all of the silicon initialization code that we can't give you in source code form rolled into a single binary that's as small as possible. That's kind of what an FSP is. So the theory is if you're building a firmware image, we can give you the maximum amount of source code for the things that we can open and give you the one pluggable module, right, with a single in, single out kind of interface. So things like memory initialization, how do we do training? There are complicated algorithms in there that we can't publish the code for because it's in NDA documentation. And oh, by the way, the chances of actually needing or wanting to mess with that code anyway are pretty slim, it turns out, right? Most people aren't going to be able to do much to improve memory auto scan algorithms that are in there. So that stuff is sort of rolled into this FSP. So you will see out on TianoCore that we're starting to get, I think downstairs we have the Minomax boards. So we're getting to the point now where there's a source code release for that board, so you can reassemble your own firmware. It does have an FSP, so the silicon initialization memory reference code, that's in binary form. But everything else is there, up to and including all the tools to reassemble an image and flash it into the platform. And that's a model that I would like to see more prevalent on more Intel boards. So I'm working on getting at least one instance of systems in each market segment class that you might care about, right? So a kind of ultramobile, maybe a phone-style, tablet-style platform, a typical client. The Minomax is sort of my proxy for that. And we're going to try and see if we can get a server class system as well and sort of move out from there. And if I can get one or two established, maybe we can grow the number out in the ecosystem. So that's kind of what we're thinking about for platform code. So this is mostly aspirational. Like I said, Minomax is there, but you know, we're working on it. I've got the mindshare within Intel now to think about having more of this platform code be published in open source form as the default. So hopefully we'll be able to see more of this as we go along. Okay, so we're also trying to get small, get open, and get fast at the same time. A lot of people tell us that when they look at TianoCore, it's this huge, great thing, right? The blingy Hummer kind of approach. And really, it would help a lot if we got through demystifying some of what's going on here. I want to get to something a little bit smaller. Anybody know what one of those is? That's an aerial atom. Okay, so there are track rats in the room. Good. That's about as much fun as you can have on a track in a street legal car. It's a stripped down, I think it's got a V6 Honda engine in the back, and it doesn't weigh but a sausage, and it's very quick and highly entertaining. But it's sort of got all the things that you would want to go fast around a track and nothing else, right? It doesn't have a full-up body shell because you don't need it. Right? You're not going to go out and drive on the track in the rain, so who needs a body shell to keep you from, protected from the elements? And I think right-sizing our code is sort of where we're headed. If you look at where we're at now with the EFI Development Kit version 2, which is the canonical name for the big project, Big specification. I think UEFI is up to 2,600 pages and change now. ACPI spec is getting up to that size too. I know Linus likes to say that any spec more than 13 pages long is only good for toilet paper, right? But it turns out that having a spec written down really does make it easier to do interoperability things. So his view notwithstanding, we're going to continue working on that. TianoCore has an SVN repository, which has a really large collection of things, right? It's like a giant toolbox with one of everything that you would want to potentially use. But unless you're really expert at finding your way through toolboxes, figuring out which pieces you need is tough, right? So really what we're trying to do is make a bit more sense out of this. So we're going to switch from SVN to Git because we're told that everybody has sort of moved on to distributed source code management now, and it's about time we caught up. So, you know, belatedly, we're trying to get there. We really want to get better right-sized trees. So on the open hardware platforms, very minimal amount of firmware. Typical clients are going to have more features, and servers are going to have more and more sophisticated features as well. But we want to be able to help you find your way to the project, and then depending on which market segment or platform type you're at, go find the pieces that matter to you without having to swallow the entire toolkit first, as it were. One thing I want to pick up in here, again, this is more of an Intel thing than anything else. BWG stands for BIOS Writer's Guide. That's a document that has all of the interesting arcane magic that tells you something about how the platform code pieces work. It's typically been a NDA document that Intel publishes. We're moving as many things out of the BIOS Writer's Guide as we can into the open white cover documents. We already published chipset information at launch of the chipsets in white cover now. That all used to be in the BIOS Writer's Guide. And there's more where that came from. So over time, we're moving more things into the public specifications. Okay. So speaking of fast, speed matters everywhere. We spent a lot of time focusing on boot speed in client systems. I think we've done reasonably well in that, right? Most systems are booting a lot faster than they used to maybe 2 generations ago. Servers, we've got a lot of work to do though. There really hasn't been any focus on boot speed over there, and it's starting to be a real issue, especially in like IP data centers where they're telling us that they're doing reprovisioning work, right? If you're multi-tenant kinds of things where you're leasing servers out to people and you need to reconfigure them in a big hurry. Turns out that boot speed is actually an important piece of your cost structure when you come right down to it. And don't forget virtual machines. So there's lots of work on the QEMU related project where we have virtual firmware, and we're trying to make that as applicable to any virtual machine context as possible as well. But again, it hasn't had a lot of focus until relatively recently in terms of getting it right. There's an IBM paper that was published in 1969 that talks about human factors and what human perception of instantaneous looks like. And I refer to this a lot. So my goal is that we get to indistinguishable from instant. And it turns out the study proves that if you can go do anything faster than 200 milliseconds, people can't perceive the difference between that and literally instant. So I will be done with boot speed conversations when we can get down to 200 milliseconds and you see your OS, right? So again, we have a ways to go, but at least we've got a goal. And of course, if it waits more than 2 seconds, something's wrong. Don't light up the head for 2 seconds, that's a problem. And I mentioned the bug tracking thing internally. We're working on, that's probably the biggest shift for Intel we'll have to make. All of our bug tracking on the things that we do for TianoCore is on an internal database that has all of our silicon debug stuff in it as well as software debug stuff on it. So I can't give you guys access to that for obvious reasons. So we've got to separate out all of the firmware bug reporting and put that in a separate repository, and we plan to do that. So I'm hoping that that will help make it go faster as well. Okay, so let me close out. I know I'm running a little bit long here. So if you're in a member company of the UEFI Forum already, then if you're not helping, you have the opportunity to step up anytime you feel like it. So please, come help us if you can. To participate in the work groups, there is a contributor level membership that's sort of required. Adopt a membership to be able to use the spec to go write implementation work is a freebie. The contributor membership is a $2,500 membership fee to get in. So for most corporate entities, that's not a huge barrier. So if you're not a member company and you want to help us with some of this stuff, that's perhaps the way to go think about that. We're going to add a hosted mailing list that will be completely open participation on the website. And we're not entirely sure what people will do with that, but I imagine there are a bunch of questions and complaints and suggestions that we'll get via that channel. It's not quite up yet, I think, but it's going to be real soon now, maybe. Hopefully within the next week or so. I mean, literally, we asked the infrastructure people to go put it together for us last week. So if you're familiar with Mailman, it's one of them. So it's just a mailing list that we can do there. There is also a place to report security issues separate from that. We're very concerned, obviously, to avoid malware vulnerabilities as much as possible. So there's a incident reporting kind of a facility there. And the nice thing about that is if you report it through us, we'll give that alert to everybody amongst the membership that's signed up to participate in that. So it's a quick way of getting vulnerabilities well distributed. Please help us get the open source project right. We're stumbling along, we're doing our best. I'm trying to find a community manager, for example. And my assumption right now is that nobody else is going to pay for that if Intel doesn't, so I'm sort of looking to get Intel to step up and do that. But that's only because logistically that's what I see as required. If there's somebody else that would like to have that job, let me know, right? That's the kind of thing where we'll step in and do it if nobody else wants to, because it sort of needs doing a lot. There's a lot of work to get done there, but it's not like we're trying to corner the market on all of that kind of responsibility. We'd love to be able to share it more. So let me know if you think there's somebody interested in that one. And there are a number of presentations that follow this one. We're really trying to share information so that you can tell us where we're doing things right, where we're doing things wrong, how we could maybe change the approach a little and do a better job. So I'm really anxious for engagement and productive conversation as the main outcome of being here at all. So with that, that's kind of the end of the remarks. Anybody got questions that I can address? Uh-oh.